What's up, gang? So today basically we will discuss hydrolysis of p block element. So the thing that we need to remember is in hydrolysis of p block element, the central atom always has a del positive charge, and the second thing is the it must have the central atom must have empty d orbital or even a p orbital. So, and another thing I would like to mention is the oxidation state does not change during hydrolysis. So there are a few exceptions. I will tell you guys about that later on. So in NX3 type of compounds like NF2, NX3, NF3, NCl3, NBr3, NF3 does not get hydrolyzed because it has no MDD orbital and NF bond length is very small, which results in high bond dissociation energy, which is why NF3 does not get hydrolyzed. As for NCl3, it is the electronegative difference between them is very small. In a Pauling scale it is less than 0.5. So this bond is actually not polar, it is non-polar. So in H2O, Cl will take the OH and the hydrogen will go there, and after three times the reaction happen, NH3 will form and 3 HOCl. Remember, we have to, yeah, that's it. I mean, no, actually that does not work here. NBr3 become NH3 plus HOBr. uh, PX3, PCl3 hydrolyzed become H3PO3 plus 3HCl. No change in oxidation state. So PCl3, plus 3, it becomes H3PO3. 3 to the 6, 3 eliminate, plus 3. That's it. PBr3, H2O, H3PO3 plus 3 HBr. PCl5 plus H2O becomes H3PO4 plus HCl. The real mechanism is it becomes POCl3 first, then becomes H3PO4. We also studied this type of reaction in organic chemistry. PF5, normal condition, no reaction. It does not react in normal condition. Let's go to NOx. N2O3 plus H2O, it becomes HNO2. So if a question asks what is the anhydride of HNO2, it is N2O3. This only happens in very low temperature as N2O3 is very unstable, so it breaks down into NO and NO2, whereas HNO2 is also very unstable. And by the way, see this, the oxidation state is the same, plus 3 plus 3. Now let's move on to N2O5. N2O5 plus H2O becomes HNO3 plus 5, that's it. P2O5 plus H2O becomes H3PO4 plus 5, same oxidation state. P2O3 plus H2O, H3PO3 plus 3. N2O4 plus H2O, HNO2 plus HNO3. Here we can see that the oxidation state is plus 4, but we know that no acid exists where oxidation state is plus 4 of nitrogen. So what will we do? We will make two acid in from which one of them is going to step up and one is going to step down. So for plus 4, one will become plus 5, one will become plus 3. So HNO2 and HNO3 will form. Now let's move on to 16, group 16. SO2 will become when hydrolyzed SO3, H2SO3. SeO2 will become when hydrolyzed H2SeO3. It's pretty basic. This is also sulfurous acid. You guys already know it. 6th, 7th class, something like that. We already studied that. Selenium. Now SO3 becomes H2SO4, sulfuric acid. SeO3, selenium acid, H2SeO4. Similar to this, plus 6. Now let's talk about hexafluoride. SF6, SeF6, TeF6. SF6 is inert, does not hydrolyze because the sulfur atom is completely surrounded by the fluorine, so such that it does not react anymore. These two actually do get react and form TeOH whole 6, TeOH 6 times. SF4 when hydrolyzed becomes SO2 plus HF. Now let's move on to group 17. Group 17, we know what acid of chlorine exists, like HClO, HClO2, HClO3, HClO4. Now when Cl2 is hydrolyzed, it make HClO. When ClO2 is hydrolyzed, it make HClO2. You guys can see that the oxidation state is the same. Yeah. Okay, so for group 17, Cl2O, H2O, it becomes HClO, ClO2. ClO2 is plus 4 plus no plus 4 as acid exists. So what we're going to do is make go step up and a step down, HClO2 and HClO3. For Cl2O6 plus 6 oxidation state, same HClO3 plus 5 and HClO4 plus 7 step up. And okay, now moving to the interhalogen compound, for example. So basically the more electronegative will form HX, and the lesser electronegative will make HOE, the OH type of acid. For BrCl, the higher electronegative element is chlorine, so HCl will form an HOBr. For ClF3 plus H2O, HF will form, and you guys need to conserve the oxidation state. So plus 3 here, plus 3 here, which will form HClO2. Yeah, 2 2s are 4, minus 1 3, perfect. ICl will become HCl plus IO, wait a minute, HOI, HIO, whatever do you want to call it. ICl3 will become HCl plus HiO2. Now moving on to group 18. Group 18, the nobles, they actually partially hydrolyze and fully hydrolyze. For xenon F4 plus H2O, it becomes xenon OF2 plus HF. XeF6 plus H2O becomes xenon O2F2 plus HF, or xenon OF2 plus HF, and fully it's just xenon O3 plus xenon, because it does not exist in that state. So 2 1 0 and 6. Whereas for this one, xenon O3 plus HF, F6 directly becomes this. Pretty damn easy, really important, super important. Yeah, that's it. Thank you.